Right, my dear students, today now we are going to learn the second part of the tutorial. So in this we are learning very important thing, that is how chemical reactions absorb the heat. So when the chemical reaction releases heat, we call it exothermic reaction. So here this experiment number 3 gives you an idea. During some chemical reactions, the heat energy is absorbed from the surrounding. So what do you feel? You will feel cool because the reaction absorbs the heat. You are in the surrounding, so you will feel cold in that area. So, but we don't use our feeling to measure the coldness, the temperature. We need to use the thermometer. Now let's see what we need for the experiment. The objective is this: observing heat change in the reaction between citric acid and sodium bicarbonate. Citric acid, very weak acid, and sodium bicarbonate is you know that it's coming from carbonic acid and sodium hydroxide. It's nearly a weak basic salt, right? So let's see what we have here. We need a beaker, solution of citric acid, solution of sodium hydroxide, sodium bicarbonate, and a thermometer. So you will observe the reaction. Now from the reaction, try to get the maximum observation and try to understand how the procedure is carried out.
Hey guys, this is Luke from JNLCO, and today we're doing a quick little endothermic reaction with citric acid and baking soda. An endothermic reaction is a reaction that produces doesn't produce cool, but it absorbs heat, and so it drops the temperature really fast. So we have our LabQuest probe here. Brighten it up. We have our LabQuest probe, and we're going to put it into this solution, this citric acid right here, and I dropped it. So that way, when I pour the baking soda in, you can see the whole entire thing while it changes. You can watch it. So I'm going to take the baking soda, pour some in a cup. There we go. So here's our baking soda, and here is our citric acid. So I'm going to move the camera over a little bit so you can see the reaction, and I'm going to turn this to the side so you can see it a little bit better. So I'm going to pour this in first, and I'm going to put the thermometer in. Try not to get stuff all over the thermometer. So pour that in. And if you watch on the LabQuest, the temperature is starting to drop. It takes a couple minutes, and the temperature keeps going down and keeps going down until it gets really, really cold. I'm gonna feel it. Oh, it's actually really cold. And the reaction is over.
So let's go to the observation again. The temperature of the system decreases during the reaction. The container, you have seen that temperature is declined. Now the discussion is the most important part in this, because we conclude one thing here, simply the reaction absorbs the heat. But the discussion is this: the heat energy absorbed in the reaction actually it should be from the surrounding. That means it absorbs the heat energy. As energy is absorbed, products have more energy than reactants. That's the most important part. You can see here, previously in exothermic reactions, reactants had much energy than products. But here, the products have more energy because you can understand, if I get reactants and they absorb heat and form products, that means products are having additional heat taken by absorption in there. So they have more energy, the products will have. So that's the next part in that. Now, these type of reactions that absorb heat from the environment or the surrounding are called, now the opposite term of exothermic, endothermic reactions. So let's see, you know that what we're going to discuss next is how to draw the energy level diagram for this. So first of all, we need to understand that reaction idea. That is, reactants absorb energy and form products. So the products have much energy than the reactants. So this is the normal diagram you have learned. Now there's no worry, but only the small thing you have to learn is the energy levels. I'm again saying the products are at a higher energy than the reactants, the reverse of exothermic reactions. And the reactants will go to products, so the arrowhead should be upward and energy is absorbed. You can see it is absorbed in here. So that's the only difference in this. I think you can understand very properly. So let's try yourself to get the maximum benefit of this theory. Now, the process of photosynthesis utilize carbon dioxide and water as reactants with the presence of sunlight to produce glucose and oxygen gas. So that's the one of the reaction that happens in plants. It's a complicated reaction, but overall reaction, it absorbs the heat or the thermal energy or light energy from the environment, right? So actually from the sun. So we are going to write the balanced chemical reaction for this above process. That's a simple thing, because in the second chapter after tissues lesson, photosynthesis lesson, you have learned how to write the balanced chemical equation. So let's write that. You can tell me when I'm doing the writing. So you can see here, we need carbon dioxide and we need water. Not actually we, the plants need. So they release or produce C6, H2L, O6 and oxygen. This is the reaction. Now the energy is given. So energy is given. So I will put energy in this side for the reaction, and when you balance the equation, you get here, you're going to put 6 carbon because you have 6 carbon, 12 hydrogen, you have 2 times 6, then it will become 12. So altogether you need extra 12 oxygen, because here 18 oxygen are there, so I put 6 in here. So in that side also you get 18 oxygen. So that's the balanced chemical equation. Now draw the energy level diagram for the above reaction. We are very much confident to draw that. So we know that this axis we label as energy. Remember the unit, kilojoules per mole, right? So now 2 levels we get. So what will be in the lower level? The reactants. Yes, the reactants in the lower level. Reactants. Then the products will form at a higher energy level. Products. And this reaction is having the pathway upwards because reactants to products, and this reaction absorbs energy. So you have a doubt now. We talk about heat, but now here one of the example, not only the heat, the energies that they absorb will be considered in here. So here you will argue that, so that is not heat energy, that is light energy. However, Bhute, that's a kind of energy. So we learn heat association, but that part is a one chapter in that whole thermodynamic world. So here they absorb light energy, we call photonic energy, to absorb and do the production. In the waves lesson you learn that electromagnetic waves carry photon energy. So that energy is absorbed by the reactants to form the products. Can you remember where it happens actually, photosynthesis? In the cell, yeah, in the cell what part? In the mitochondria. No, it's in the chlorophyll. Inside the chlorophyll, the organelle name is chloroplast. So it happens inside that. So let's see what we have the next one. That is this. Now we can understand how to do this question. Now it's chance for you to read the question, pause the video and get this done. So I'm giving a few minutes so you can pause the video and try this question. Right, hope you have done the question, so it's time to check the answer. Now listen. So you read the question, you can see the chemical substances. Calcium carbonate is thermally decomposed in industry to produce calcium oxide and carbon dioxide. Thermally decomposed means you are supplying heat energy to break down calcium carbonate into these two products. So we are writing calcium carbonate is heated So if you want, you can plus heat, you can write, but it's not actually needed, but I will write it to make it confirmed. Now it dissociates, thermally decompose into calcium oxide plus carbon dioxide. That's it. So check the answer till the equation is balanced. Yeah, it's balanced, you know. Calcium 1, oxygen 3 here, and carbon 1. Right. Now drawing the energy level diagram very simply. Now you know, you can tell me. So you can see here kilojoules per mole is the unit of that. So you can get two energy levels. So again, this is an endothermic reaction because you are providing heat to decompose this material into two products. So you can see the reactants in the lower level. So the reactant is only one thing here, thermally decomposing, and you can see it will turn into calcium oxide plus carbon dioxide, and this reaction is absorbing energy. So very simple, right? So I told you in the beginning also, grab the knowledge of this lesson, you will get the full marks, right? Most of the reactions in the laboratory are exothermic. Very rarely we can find endothermic reactions like this. Okay, so actually when in any carbonate in the group 2, right, any carbonate, they are able to decompose, thermally decompose, but actually calcium carbonate decompose very rapidly than other carbonates. So like that, you can understand the behavior of different chemical substances due to the change of temperature and as well as change of heat energy. So now I hope that you got the satisfaction about this topic. So it's your chance as homework. You can do these questions. These questions I obtained, or I just crop it and found it from the textbook here. So you can go to the textbook and find out the questions in here for that lesson. So get it done and check the answers, and you can pause the video and do the questions, or either close the video and do the questions and come back to the video and see the answers, because I'm going to discuss the answers. Right, it's time to check the answers. Let's see. What do you mean by an exothermic reaction and endothermic reaction? That means they're asking the definition. So check your answer. Exothermic reaction, a chemical reaction that releases heat to the surrounding, right? Endothermic reaction, a chemical reaction that releases, so actually absorbs energy from the surrounding, right? That's the thing. B part. Are the following reactions exothermic or endothermic? That's the major problem you will get, because you have to understand and you have to practically get the knowledge what reaction is this. Burning a candle. Burning means the candle is there, we light up the candle, you will feel the heat. That means it's an exothermic reaction, right? Putting a piece of sodium into water. So you have seen the previous video also. It's an exothermic reaction. Dissolving the fertilizer urea in water. You know that urea is a salt material. I told you that when a salt dissolves in water, it cools down the temperature. So it's an endothermic reaction. Right? Next one. Adding glucose into water. You know that thing. The hot tea starts to cool down because the heat energy is absorbed from the tea when sugar dissolves. Glucose is another substance. Sugar is sucrose. Glucose do the same thing. So it's an endothermic reaction. Adding water to quicklime. Here this is an important thing. We are not touching this name recently. We have not done this name. But quicklime is the thing we have to understand what it is. Quicklime is calcium oxide. Calcium oxide is in Sinhala we call hunu, right? So that thing start to heat up rapidly. If you've done that experiment, because when the constructions are done, they are buying these packets and they add water, dissolve it and apply the wall, right? So it becomes pale color in the beginning, and when the carbon dioxide reacts with the paint or the liquid medium, it becomes white color in the wall, right? So this thing, when it add to water, it start to react and produce heat, right? That means it is an exothermic reaction. Now, the quantity of heat evolved during the following reaction is this much. Now they are telling amount of heat, right? This reaction, sodium reacting with chlorine, and it releases sodium chloride. So equation is already balanced. Here they are telling evolve. They are not just telling release, they are using another word, evolve. Evolve means releasing. So it means it's an exothermic reaction. So we have the idea to do that. So let's see what we get. So make sure always practice the flow of the diagram. First, don't forget energy. Right. Now labeling has been done. So now we are going to draw the chemical substances in different energy levels. So in an exothermic reaction, tell me which one is at the higher level, the products or the reactants. Yeah, the reactants are in the higher level. The reactants will start to become products. That means arrowhead is downward, becomes products by releasing energy. See, very easily you get the answer. So hope you got the idea. So always think positively in science, because if you grab the subject will respect you. If you hate the subject will hate you. So keep it in mind, learn positively, take the maximum idea, become successful. Have a nice day, everyone. Bye bye.